So here we are. We've made our main menu. We've made our main menu method that we call right off the bat when we start our main. We make our title, of course, that's first. And then we make a main menu. So we call two methods and we're calling a main menu. So we've got start a new game, load a new game, and create a new character. So I say we start a new game, shall we? Let's just go down here and make some methods for starting a game. I'm going to say private because I don't want anyone else messing with this. Start a game. Not really sure what we're doing, but I just make it a method called start game. So what are we actually talking about? What is a game? What we want to do a role-playing game, so we want to crawl through a dungeon with a character and get treasure, open chests, try to dodge traps, all that kind of stuff, right? So one of the best ways to keep game data is in external files. It's a great way to do it. If you're trying to sell a game and you don't want anyone seeing your stuff, there's ways to hide your game data, but we're not worried about that right now. We're just going to keep all this information in files in the file system. And one of the best ways of keeping data that can easily be read inside of your C# code is via JSON. JSON stands for JavaScript Object Notation. So we're just going to pretend we're making a game. We're starting the game. You started the game. Great job. You know what? We might as well do our character creation too right now. Create character. Man, this is awesome. We're almost done with this game. I kid. Quickly, do you notice that these are kind of darkened out and there's our little ellipses? You guys know by now we can hover over these things and we get the light bulb, or we can just read this. It says, hey, this is not even used. So basically we've made methods that aren't getting used. Not the end of the world, not an error, but it's a handy little reminder that, oh, shoot, I need to actually use this. So I'm gonna go back up here to my make menu where I'm doing the user main e equals s, and this is where we would actually call the start game or create the character. But I remember something before this. I talked about down here when we made the else statement. This is for all the times that the user doesn't input the three things that we want them to input up here, right? But this is just gonna write the line out again, and then it's gonna execute all the way through and be done. Let's actually watch this work and see our problem. All right, so I'm going to not choose what I'm supposed to choose. I'm going to choose a Z, hit enter, and it said, hey, you chose a Z, buddy. You didn't pick the right letter, which we made it say that, and then it gave us options again. But what happened? Well, we didn't do a read line, right? And so our program is over right here. Game over, not fun. So we could come down here and say the same thing we did here, right? But you see we're going to have the same problem. What if down here we don't put the three letters in? So what we're running into here is our first need for a loop. There's several looping structures, but this loop is called a while loop because we want to keep doing something while something is the case. What is the case? What is the problem here? The problem is we want to know if the user picked if the user input was valid. So we need to make a variable to hold that. Let's go up to our variables here, and we'll call it input valid. Actually, that's not the case. We don't want to know if the input's valid. We want to know if the input is invalid. So we'll say invalid equals true. Now, do you guys remember from the types that we talked about last time, what is true and false? Remember the type that is a true or a false? Let's hover over this and see what it is. Oh, it's a Boolean. It's in the system namespace. It's a Boolean. It represents a true or a false value. So we got our first Boolean. Congratulations. So before we do our if and else statement, we're going to write a while loop. We're going to say while input is invalid, while input is invalid, we're going to keep trying whatever's inside of here. And this is what we want to do. So I'm going to stick this in here. We're going to still have this. We're going to write this out. We don't, now you see the red squiggly here? It's because I tried to re-declare user main. User main's already been declared inside of this method. I don't have to do this. I don't want to do this again. I'm going to say that again. Okay, so what this loop is saying is while this is invalid, keep doing this stuff, correct? How do we make this continue to stay invalid? We need to set it to true or false depending on what happens. You know what? I really don't like this. I really don't like the name of this. I don't like something that's a negative name, invalid, with a positive value. It's confusing. So let me show you something else. Input valid equals true. Nope, input valid equals false. So we're going to change this to input valid equals false. I like input valid because it's actually a true statement. When input valid equals true, it means that the input is valid. Otherwise, when input invalid equal false, it means it was true. It gets really confusing. So we're going to rename this input valid. And so the problem here is we don't want to keep doing stuff while the input is valid. We want to keep doing stuff when the input is not valid. So how do we say while not input valid? Well, you can do that. You could do a couple ways. You could say while input valid is equal to false. Remember our double equals? We don't want to do a single equals because that changes it. So we could say while input valid is equal to false. That's perfectly valid. A shortcut to that is an exclamation before it. That means the exact same thing. So while input valid is not true, keep doing this thing. We come down here, we say, okay, input valid is set to false, which means it's not true, so let's come down here. The user gave us an S or an L or a C. So if we get in here and we know we're right, it's at this point we want to say input valid equals true. Single equal because we want to change the value. Now this loop will no longer loop through. Down here is where we would say, we know that the person has screwed up. We're going to say input valid equals false. Now you might ask me, Todd, why do you got to put input valid equals false? You already set it up here. And if it gets changed, you're going to be outside. You won't need this. You're right. This might be a redundant statement, but for safety purposes, until I have fully tested it and understand all the different actions or reactions of the application, I'm going to go ahead and be safe on the logic and say input valid equals false. And then I'll rewrite this again. And then I'll do this again. Let's see if this works. If this works correctly, this should continue to ask me for this information until the cows come home. In other words, until I do it right. Once I do it right, it should be done and be finished and go out. So I'm going to say D. And it said you didn't choose the right thing. Blah, 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 blah. And it's going to ask me again. Let's just see this work. Let's go back over here to our debugger. And I want to stop it right here. And now I'm going to go back up here. Console doesn't like to scroll. An E. All right, so it's asking itself, okay, is input valid not true? It is not true, it's false. So it's going to step back into here. It's going to look and see if I've given it the right letter, which I haven't. I've given it an E to upper. Remember we did it to upper. So it's going to say, okay, you're still false. Blah, 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 blah. And there we go. So let's just see how many times. I'll take this away now so I don't have to do this over and over again. And I'm going to come back down here. I'm going to say Q. How about a Z? How about an X? How about a V? How about a B? I can't get out of this thing. Or I could just put the right letter in, correct? Let's do that. Let me come here. Put this breakpoint on again and watch this work through correctly. All right, fine. Let's start again. All right, back to our program. We're going to say, yeah, it's still invalid. Now we're going to check this. We finally got here. We write the line. We set this to valid. And now watch what happens at the end of this loop. It checks this, and it is no longer not valid because it's actually true. So boom, it's done. The loop is finished. And our program is complete. That's a while loop, guys. That's how we can handle that. So there's another problem. Okay, now that we're in here, let's check and see exactly what we have. If it's an S, we're gonna say start new game, start game. Remember the method we made down here? But if it's a C, else if it's a C, then we're gonna create character. But if it's a L, then we're going to load game, which we haven't made that yet, but we'll go there. And then we're also going to make sure we make input valid equals true. Here we could just click on our little arrow. Come on. And it made me program load game. It's going to throw an error. I'm going to say, no, you're not. And so look at that beautiful bunch of code. Do you guys see stuff here? Do you see any issues? I know most of you are probably brand new, but do you see any issues with this? This is laborious. This is ugly. This is nasty. I'm doing a bunch of the same stuff twice here. I'm doing this twice. So this is our first key programming principle we're rubbing up against. DRY. Keep it dry. Do not repeat yourself. If you repeat yourself, that's a problem. It's probably something that you could be doing different. First of all, we're probably only going to do this kind of stuff twice, but I don't know. I don't know how many lines we might have. I don't know how many statements we're going to want on the main menu. So I want to take these three things right here because we might add more to this, and we're doing it down here as well. And I'm going to right click on all three of these lines. I'm going to say quick actions, which is I just clicked on the light bulb, extract method. This will make a method for us. And it's set up for a rename because it knows you don't probably want to name it new method. We're going to call it menu options, make menu options. And so down here, rather than do these three again, because I'm going to DRY, do not repeat yourself, I'm going to make menu options. So you can, oops. And look, it made it for us. It knew that I didn't have to have anything returned, so it returned it void. And it made the menu options. Very nice, very nice. Now I still got this, it's doing the same thing twice, but I think what we can do here is rather than put this down here in our loop, we've probably got a problem with our loop. So I'm going to take this out and I'm going to stick this inside of my loop, which means I won't need it here again because it's already there. Because if I'm invalid and I have to loop through it, I'm going to go over this again. So every time I go over this, I'm going to hit this again. I don't need to write it down here. Also, if I want to show the choose, I can put it down here, but I don't think we need this message anymore. We're past that. I was showing you guys how to do that. All right, so this is much cleaner. We're not repeating ourselves anywhere. I could probably move this below. If the user does not choose the correct option, we give them a message and we make menu options again and we set input valid equals to false so that the while loop continues. Now look at this thing. This is just ugly. If user is this or is this or is this, then okay, then but really then you got to ask again. So we're gonna use a different statement called a switch statement rather than an if else. This whole thing could probably be better done inside of a switch. Now look, I pushed SW. You can see that it brought up switch. Now I'm going to tab. You can see right there if you look over right here, this will tell you tab twice to insert the switch snippet. So this will set all this up for you. Just tab twice. Boom. And it's saying, what are we switching on? What are we switching on? What's the deciding factor in all this? It's that user main. So there we go. Now look at that. Do we really need user main for anything? If that's our switch, I don't think so. Actually, we could probably get rid of user main and just go with this. All right, so we're going to switch on this input, and this is how we do it. We say, okay, a switch is like an if else, but it's written a little bit better, more terse. So instead of saying if this or if this or if this, we're going to say if the case is S, Then we're going to do the stuff we want to do with S. And what do we want to do with S? Start game. And then we tell it to break. If the case is C, create character. Break. Oh, B-rack every time. If the case is load, now default is, what if none of these turn out correct? Why is that? What's going on here? Oh, I didn't put the break on. Sorry. If this input is none of these, then this is what happens, which is what we're doing down here. So we can take this. Oops, I don't want to do that. We can take this. I want you to see this first. That's why. And put it down here. And so what we just did in 51 to 74 was that 23 lines of code. With this, we were able to do in 34 to 4 to do in 15. So, and look how much cleaner that looks. While input is invalid, is not valid, while input is not valid or input is invalid, do this. Boom, boom. This should work exactly the same way we just did stuff. Let's load again. Great job. I like to be positive. Let's run it and see how this works. Should work exactly the same way. D, T, K, C, or do L. Great job. Oh, look at the bug we just made, guys. S. What's not happening? Our loop's not breaking. Plus, we're getting 2 new lines every time. I don't like that. That's something we can fix. So I found an issue. Can anybody tell what it is? I'm acting like I can hear you guys talking. What'd you say? Just kidding. Of course I can't hear you talking. We forgot to set input valid equals true. So if any of these are correct, we have to set these to true. Or else we're stuck in our loop for all time. It's like a bad Twilight movie. Twilight Zone movie for all you kiddies under 35. You have no idea what I'm talking about. Also, I don't like the double N in this make menu option that we're calling every time. How can we fix that? Let's get rid of that. Again, I don't like it here, but what I could do is put the 2 new lines at the end of this last line, put them inside the quote, and now I'll get my 2 lines only once after the title. Let's try this. D, bad. T, bad. G, bad. L, good job. Game over. There we go. Looking good, fellas. One thing I would like is a single line. Okay, fantastic. Let's run this one time. F5, just to see how it looks. It'll probably look a little bit more formatted. Now, I'm doing control and scroll mouse button when I make this larger as well, in case you were wondering. D, not good. W, not good. R, not good. So that's a little bit better spaced out. I like that. L, good job. Game over. Fun game. All right, so back to what I was talking about 20 minutes ago. JSON, JavaScript Object Notation. JavaScript Object Notation is just a way to form your data in a text file so that the computer can read it. Code can read it, JavaScript can read it easily. So what I think we're going to do is we're going to create JavaScript object notation files that hold the adventures and hold the character sheets. And we'll load those, we'll read them, and we'll play the game. So let's start creating a JavaScript object notation adventure, our first adventure. So I'm going to go up here to File, New, File, Control N. And let's see if they have a JSON thing. They may not have. Yeah, there's JSON file. I could actually start with just a text file and then save it as .json, because all JSON is a text file. I could open up Notepad right here and could create a JSON file right in here and save it as .json, but I don't want to do that. I want to show you this way. So we'll say .json file. Calling it json1.json, meh. We'll name it something different. So this is a JSON file. JSON file is just, like I said, it holds data. It has 2 curly braces. That has to start with 2 curly braces. Now, next in a JSON file, we create pairs of data. So what's one piece of data we're going to want in this? We're going to want a title. So you put the title in quotes, you put a colon, and then you put the actual data that you want. Let's call it the Duke's Chalice. I just made that up. That sounds cool. The Duke's Chalice. All right. So when you're done with a line, if it's not the last line, you do a comma, and we'll do description. So we'll open this file up, read the title, read the description. Description for now was going to say this is the starter adventure. Have fun. Okay. And that's it. That's our JSON file. So now we got to save it. Where are we going to save it? Let me show you something. So I'm going to say file, save as, and let's go to our file structure. All right, here's our file structure with our solution file and our one folder that holds our project, our single project. There's our project file that controls all this stuff. There's our one program class, and we have an OBJ file that has settings in it, and we have a bin file. The bin file is where the application and all the stuff the application needs gets boiled down to. So not bin file, bin folder. So if I click the bin folder, there'll be different environments. So a debug environment, a release environment as we move through getting it more ready to to give out to the masses. But right now we're going to be in the debug folder. And so that's the .NET Core framework. And here's all the files we currently need to run this application. So I'm going to call this initial.json. I'm going to put it in a folder in here. This isn't best practices. If we were to release the game, we'd get a package builder. You've seen them where an MSI build or just an exe that actually puts things where you want them. But right now we're going to keep it simple because we're learning to program, not how to deploy yet. So I'm going to make a folder called Adventures. You can imagine we'll probably have a folder in here called Characters and maybe other things as well. So in Adventures, I'm going to do it there. I'm going to put initial.json. All right, we have an adventure. Not very much stuff going on in here right now, but let's get this thing open and read it into our program. So where do you think this should go? Probably in Start Game. So in Start Game, let's open the file. To open the file, we got to tell the application where our file is, right? So we create the base path of where it's at. So we're going to create a variable called base path. This is where the adventurers live. There's my string interpolation $. And we're going to use a thing called app domain. It comes with the system. Remember I told you system's got a bunch of cool things. Part of system is app domain, represents an application domain, an isolated environment where applications execute. So we're going to say our base path is our app domain dot current domain dot base directory. All right, now this will put us wherever the program is running. You guys remember where the program is running? It's running in the bin directory, right? And so this gives us the exact right path, but it's our application, or I'm sorry, our adventures aren't in bin, they're in adventures. So we can just write, we do not need a slash adventures. This is good enough to get our base path in this variable right here. Now we need another one. Let's create an adventure, our initial adventure, and we're gonna read it in and we're gonna convert it to our adventure. Here's a problem though, we don't have a class called adventure, do we? So, yeehaw, this is our first chance to create a custom class. Congratulations guys, you're creating a custom class. So I can come over here and I can say right click, add new class, but I don't want to do that yet. I want to keep this looking good. I'm not going to make this mistake. I'm going to actually create a folder to put this in because I know there's going to be a ton of adventure-y things. So I'm going to make a folder called Adventures. Inside of Adventures, I'm going to create a new class called adventure.cs. Yeah. class. There we go. Look at that. Here's our brand new class called Adventure. It comes with a bunch of default system statements. I'm sorry, a bunch of default using statements. Dinner's done. I'll be right back. Okay, wow, that was delicious. Let's continue. As I said, it comes with a few default using statements that it believes you may use. Here's our namespace. You can see the namespace is RPG Console Tutorial Series .adventures. It's actually calling out the folder so that when we namespace it, it knows where to go. And here's our class. What's the first thing you see that is wrong with our class? There's no access modifier, which means right now it's private. So I couldn't call var I couldn't create a new instance of our brand new class we made. Red squiggly has no idea. It doesn't know where it's at. Nothing. So I'm going to go over here and I'm going to say we want this to be a public class because we want things to use it. Hit save. Come back over here. Now if I was to hover over this, oh, I'm sorry. I got adventures. Adventure. Okay, hold on. Let's go back and make sure I want you to see this. So go class. Adventure. You notice that when I did make it public, then it could find the namespace. But right now, it probably can't even find the namespace. A type or namespace adventure could not be found anywhere. Why? Because it's private. So if I go back over here and I say public, save it, come back over here. Now I should get the light bulb that says, did you want to use RPG Console Tutorials Adventures? Well, yes. Yes, I do. And looky there, you have just instantiated, we made an instance of or instantiated your first custom class. Does nothing, but you made an initial adventure. How awesome is that? I think it's pretty awesome. Let's go back over here. I'm going to show you something. Here's a trick I use all the time, every single day when I am programming. A lot of times we'll add using statements that we don't need, or Visual Studio will add using statements you don't need. You want to right click up in here somewhere and say remove and sort usings. Later on, I'll show you how to sort them in a good, proper way. But right now, we'll just use the default sort. And we'll say remove sort and sort usings. It's going to get rid of all the ones that weren't being used. You can see that because they're grayed out, they're not being used. We're not doing anything yet. So we're going to get rid of them. We're going to remove and sort. We'll probably end up needing them in a little bit, or at least a couple of them. But right now, we're going to get rid of them just to make this clean. Okay, so the anatomy of a class. Do you remember what we said classes were made of? They're made of properties, methods, and one other thing, they're made of a constructor or constructors. You can have multiple ways to construct this adventure. Every single class you make comes with a default constructor. The way you define a constructor is you simply say public and you say the exact same name as the class. That right there is a constructor, but it's your default constructor. This is what is happening in the background if you don't have anything. It's just implied. You're just going to have an adventure that you're going to construct an instance of adventure that is taking nothing in. That may not be real clear right now. Don't worry about it. We'll get it figured out. If I wanted to do some things in the initial construction of my class, then I would make a constructor that had initial arguments that you would pass in whenever you constructed one. That's a different constructor. So then we have public void my method. Remember we have methods in here, and I made it public so that we can call on it. Whoops, what am I doing? And I made it public so we can call it outside of our class. And of course we have properties. So remember, properties are like the things that make the adventure what it is. It's the descriptions. It's not the verbs like my method, but it's the things that belong to the noun. Our noun here is adventure. So what things would belong to it? Well, title would belong to it, right? Just like we put in the JSON file. So I'm going to say public string title. And the way I tell Visual Studio that people can get it and they can set it is to write a get set. This is called an auto implemented property. What else do we have? Public string description. You can see it's yelling at me because I put a lowercase t on a public property. As per normal naming conventions, we like to have capitals for public properties. There we go. All right, now we have a class that has a public title string or public title property and a public description property and a public my method property. If we were to come back over here, let's save this. It's already saved, but I'm going to push it again. And let's say, okay, now we have an instance of my adventure. It's called initial adventure. So if I were to say initial adventure and I do the dot, look at what we see here. Looky there, there's a wrench that shows it's a property and it tells you it's a string. Here's the title, which we just made. This is so cool. There's some standard methods that are just kind of part of every object's base. And then look, there's my method. That's pretty cool. We can run my method now, which doesn't do anything. What does my method do? I don't know. You know how we can tell people what it does? Check this out. So if we come back over here above my method, we can do what's called XML commenting. We can write some comments that will give people who use our classes information as to what it does. If I do 3//, you'll see I automatically get a summary. So I can say, this class does this and that, and don't do this. I don't know. Now we have XML commenting. If I come back over here to my program and I do dot, and let's say I go to my method, oh, looky there. There's our information right there telling us all about it. So cool. So neat. All right, so let's wipe all that out. Not all that, just this part. We have what we need in our custom class right now to do some cool stuff. So guys, we're going to stop right there for the day. I'm already over 30 minutes. You've already learned a ton of stuff. Custom classes, instantiation, JSON, constructors, auto-implemented properties, and a lot more. I've already got the next 30 minutes recorded for the next series. So this next episode will be coming out within the next day or so as I edit that as well. We're going to create a game service engine or game service class that we'll call, which will open our files, we'll read our files, we'll convert our JSON files to our actual adventure classes. And once we get to that point, then we're ready to start diving into the game to make more classes for the game, such as treasures and traps and rooms. And we can start to create our character and load our character in. Look for episode 4 here really soon, and we will catch you on the flippity flop side. Peace.